Welcome back. Now we're going to finish up specific immunity, talking about T cells and cell-mediated immunity. So T cells have receptors, and just like B cells, every T cell receptor recognizes one particular antigen, and all the receptors on one T cell are identical, but are different from the receptors on the other T cells. However, this is different. T cell receptors cannot recognize antigens without help. So, how can T cells recognize an antigen? Well, here's a T cell. It's got receptors. There's an antigen, but it's going, I don't see you. Okay. So, what has to happen is a macrophage has to come engulf the antigen first. And then the macrophage is going to do what a macrophage does, and that is lysosome is going to break down the antigen. And then when the macrophage breaks down the antigen, it's going to take one little antigen fragment and it's going to put it on a silver platter, and it's going to go, here, Mr. T cell, do you see it now? Do you see it now? And so we call that macrophage that is presenting that fragment of the antigen an antigen presenting cell. Okay. And I'm going to show you in the next slide exactly how this happens. Okay. And after that antigen presenting cell has presented the antigen to the T cell, then the T cell can recognize it and get activated. So here is the drawing. The antigen is going into the cell that's going to become the antigen presenting cell. Okay, it binds with the lysosome breaks it down. But there is also a vesicle that contains molecules for compounds that help the cell recognize self versus foreign. Okay, and the reason for this is this fragment of an antigen is going to be tagged with something that is going to say, okay, this cell knows self from non-self, and now this antigen is recognizing as not self, okay? And so it's going to have this little antigen attached to this complex of this MHC molecule, which we're not learning about in this course, okay? And so that piece of the antigen is presented in a groove of that MHC protein on the cell surface, and that's what the T cell is going to bind to. So it's linking that foreign antigen to the self protein on the plasma membrane of the cell that's going to become the antigen presenting cell. And what that does, it allows that incoming T cell, the one that's going to become activated, to compare the antigen to the self protein right next to there side by side and say, okay, that's the self, that's the non-self. I see the problem, okay? So it recognizes foreign from self, and now it has the message, destroy cells that are carrying foreign antigens and leave cells that have self antigens, the self MHC, leave those alone. Don't harm them. Okay. So what cells can become those antigen presenting cells, those APCs? Well, as I talked about, macrophages. And as we learned, monocytes that go into tissues, those become macrophages, okay? Early neutrophils at the site of inflammation, those become macrophages. B cells can become APCs, and dendritic cells can become APCs. So dendritic cells haven't talked a whole lot about, but if you remember when I talked about skin and when I talked about the epidermis and the 4 cell types in the epidermis, I mentioned a cell called the Langerhans cell, which would cruise through the epidermis looking for stuff to phagocytize. So it was part of the First line of defense. That's an example of a dendritic cell that can become an antigen-presenting cell. Okay, so after that T cell is activated, what's going to happen? Well, just like the B cell, it's going to have clonal expansion, where it's going to make a whole clone of cells that were activated against that one antigen, because we're still going to have specificity in T cells, just like we did in B cells. But now we have something unique to T cells in that we have differentiation into different types of T cells. We're going to have helper T cells. We're going to have regulatory T cells, sometimes called suppressor T cells. And we're going to have cytotoxic T cells. T cells that are toxic to other cells, sometimes called killer T cells. And then each of these three types of cells are going to have their own type of memory T cell. So yeah, we have a lot of we've got 6 different types of clones of T cells being made. Not just clones of plasma cells and clones of memory B cells. Okay, so let's see how this works. Up here at the top, we have that immature T cell, couldn't recognize the antigen, whatever cell, like macrophage, became an antigen-presenting cell, presented the antigen right next to that MHC self protein. The immature T cell goes, oh, I recognize self and I recognize foreign now, became activated. Okay, so now it's going to make a clone of helper T cells and a clone of cytotoxic T cells. Sometimes they're called CD4 cells, CD8 cells. I'm not going to use those terms in this course. All right, so let's talk about the cytotoxic T cell first. If you look at this one, you'll notice that it has these little vesicles in it. For the cytotoxic T cell, I want you to think about this being a soldier that has a rifle with a little bayonet at the end of it. Why a bayonet? Because that's a knife, so it can poke holes in it. And after it pokes holes, it can still shoot bullets, okay? Because that's what a cytotoxic T cell is going to be doing. Now, a helper T cell kind of has the name. You might think, oh, it's going to help the cytotoxic T cell. Maybe it's going to refill the bullets or something like that. But no. The helper T cell. Oh, I forgot to tell you, those vacuoles are going to contain things called perforins and granules. I'm going to tell you what those are on a later slide. Getting back to the helper T cell. The helper T cell is not just an ordinary soldier. The helper T cell's general patent. The boss. Yeah. The big kahuna. In charge of the whole shebang. And by the whole shebang, I don't just mean the T cells, I mean the whole shebang of specific immunity. Because the helper T cell, see these little things up here it's releasing? It's secreting cytokines that regulate this whole immune specific response and also some non-specific stuff. Because we talked about how cytokines can affect non-specific immunity as well. So let me show you a couple of things it's going to do. Some of those cytokines are going to go over to cytotoxic T cells and give them a swift kick in the rear and say, get to work, young man. You got your equipment, go work. Kill some of those cells that contain antigens. Other things that cytokines are going to do is they're going to go up here to naive T cells and say, make more cytotoxic T cells, make more helper T cells. We need a bigger army of T cells. Turns the burner on. And then still other ones are going to go back to our B cells and tell them to get to work. So do you see how the helper T cell is helping all aspects of specific immunity? Yeah, it's important. All right, so let's look at the cytotoxic T cell in action in detail as I promised. Okay, so the thing about the cytotoxic T cell is that it directly attacks the foreign cell or the infected cell. So here it is, sitting around. Oh, now it's ready to get called to duty. It's got the rifle with the little bayonet on it. So here's the little bayonet. It's binding to the target cell. There it is. See the little bayonets poking into the target cell? Yes, here are the little perforins poking holes. After the little perforins have poked the holes, it can shoot the bullets. What does that mean? The little vesicles containing granules can now enter the target cell through the holes created by the perforin. What do granules do? That's an excellent question. Well, the granules in the target cell, they activate apoptosis in that target cell. Yes, that target cell is going to die. So cytotoxic T cells go and they kill target cells one by one. Oof. And here's the thing, that cytotoxic T cell is not going to die with it. It's going to separate out and move on. Target cell dies by apoptosis, but that cytotoxic T cell has more perforin and more granzymes and can go do this to another target cell. All right. Helper T cells, they're not just sitting around watching. Okay, so they were activated. I showed how they already activated cytotoxic T cells. I talked about how we're now going to have memory helper T cells. But in addition to that, I mentioned how they were going to be making more helper T cells. They do that through cytokines. Specifically, do you remember when I talked about interleukin being an example of a cytokine? Well, there's a specific interleukin they do for that. It's a different interleukin that they're going to do to activate cytotoxic T cells. And they're also going to be stimulating naive B cells so that they will become plasma cells secreting antibodies, which can then bind to the antigen, which was engulfed by the macrophage, as well as make memory B cells against that same antigen. So you would have both memory helper T cells and memory cytotoxic T cells and memory B cells all against that same antigen. All right, the regulatory / suppressor T cells, they're going to either slow down or suppress the immune response. So what this does is it prevents unnecessary damage to healthy tissue, as well as I mentioned before, prevents autoimmune disease. And here's the really cool thing. These regulatory T cells can stop the B cell response while still continuing the T cell response. So it doesn't have to turn everything off at once. All right. So overall schematic. Humoral immunity on this side where we have B cells secreting antibodies, which are going to bind to their antigens, which are extracellular. And I mentioned before 3 specific responses, and that's because I knew they were on this slide where we can neutralize them, we can activate complement, or we can put neon signs so we have more robust phagocytosis. On the other side, we have cellular immunity with our T cells, where we have to have it engulfed by a cell that becomes an antigen-presenting cell, which processes it along with an MHC component so that the T cell can recognize self from non-self, activate a helper T cell, which releases cytokines, and then we are going to have cytotoxic T cells, which can have perforin and granzyme individually kill infected cells, as well as have suppressor T cells slow down the whole reactions, as well as have other cytokines turn on B lymphocytes to have more humoral immunity. And did you notice extracellular pathogens are involved in antibody-mediated immunity, whereas intracellular pathogens are involved in cell-mediated immunity. So before you quit and move on to a new topic, here is a much more simplistic overview. I put some prompts in there. I need you to talk yourself through the whole process and make sure you know it all. I did not give you a word bank this time, but make sure you throw in as many words as you can. Go back. You need to make yourself a word bank the first time, do that, and make sure you know which type of immunity deals with the specific location of the antigens. And once again, thank you so much for all your hard work, and I will see you soon when we come back with our final video regarding immunity.